right, so we're going to talk more about the graphs, the derivatives of functions. Remember that you can pause the notes at any time, which will be super helpful, and then you can continue on. So we're going to get started. Here you'll notice it says sketch the graph of the derivative of the function. So really similar to what we had been doing previously, but now we're going to give a little less guidance and we're going to have to work a little bit more independently. So the first thing that we're going to do is I'm going to recommend that you find where f prime of x equals 0. So if you remember that from our last lesson, that means that we're looking at the max and min, since we're looking for where the slope is completely flat. Here we see a nice example at 2 with a horizontal line, lovely flat slope. Now in this case, there's 2 other points that are going to have derivatives of 0, where they're going to have horizontal tangents. We see another one at 4. And then we see our last one here, which seems to be in between -2 and -1. And I'm going to say that that's at -1.5. So we have 3 places where our derivative is 0. So if I go down here to my graph, I am going to have a derivative of 0, means that we're going to have zeros here at 2 and at 4. So those are our 3 zeros of our derivative, because it's the 3 places where the slope is flat. Now the next thing I'm going to do is I'm going to find the intervals of increase. So that's where we have a positive slope. I'm going to use a different color here. I'm going to use, let's say, pink to show my areas of increase. So again, that's where the slope is positive. So we can see that this is a positive slope from -1.5 to 2. And then again, we have a positive slope from 4 up. Now, positive slope means that the derivative is positive. And positive just means it's going to be above the x-axis, right? These are all of our positive f of x values. So we're going to put everything has to be positive from here to here, and then it's going to become negative. So if I'm going, okay, well, I have to go from this 0 to 2, and I have to be positive, that just means that we're going to go up here and back down. If you want to know exactly how high up to go, you can test the slope at maybe a middle point, like at 0. I'm not going to be that particular with you, but you want to go up. You want to be positive wherever this graph is going up, and that's happening here, and that's also happening at 4. So at 4, we're just going to go, it's going to be positive. Now the last thing you're going to do here is find your intervals of decrease. These are your negative slopes, and I'm going to pick a different color again. Let's go with bright blue. And our negative slopes are where it's going down as we're going left to right. So we have a decrease here, we have a negative slope, and then we have a negative slope in between 2 and 4. So if I'm looking at my graph of the derivative, negative slope means that we're going to have a negative derivative. That means below the x-axis. So we have our point going here. That's negative. And then again, just like last time, we're going to go negative, and then we got to go back up here. And we have a lovely graph of our derivative. As you can see, it is a cubic looking polynomial graph. And that's following the same rule that we saw earlier, where we had a to the 4th degree polynomial graph here, and the derivative is 1 degree less. If you have questions about anything regarding derivatives so far, please make sure to ask them in the comments, set up a Zoom meeting, and nominate homework questions in the form. Talk to you later.